Well, hello everyone, and welcome to this Atmos UAV webinar. My name is James McLaughlin. I'm a business developer at Atmos UAV, and today I'm going to be joined by one of our close partners, Norbert Stellard, who is the owner of a surveying company called Blik van Boven. And together, we are going to be presenting you this webinar, How to Achieve Centimeter Level Accuracies with Marlyn. Now, for those of you who this is your first webinar to join with us at Atmos UAV, welcome. For those of you who also joined our last webinar, welcome back. And what we're going to be doing today is taking a deep dive into a Marlyn use case. And this is based on feedback that we actually had from our previous webinar. So thank you to all of those people who gave us your feedback from our last webinar. Now, the plan for today is, firstly, I'm going to be giving you a short introduction to Marlyn for those of you who may be new to it. And for those of you who maybe know Marlyn already, I'm going to be perhaps giving a bit of a reminder of what you can expect from our drone. Then I'm going to be handing over to Norbert, and he's going to be giving you a use case example. And actually, it was the example which I covered really briefly in our previous webinar. What he's going to be doing is going into a deep dive of the logistics of taking Marlyn out on a survey, the post-processing workflow after the flight. How did you go from taking images and some PPK timestamps into a usable data set? And then finally, he's going to be sharing with you the results. So he's going to be showing you the best GSD and the best accuracy that you can expect from Marlyn. Finally, at the end, what we'll be doing is we're going to be going into a Q&A session. So if you do have any questions throughout the webinar, what you can see on your Zoom controls at the bottom of the screen is you can see a dark gray or black box, and in there will be an icon that says Q&A. Feel free to put your questions into there, and we'll be doing our best to answer those at the end. For those who we don't get to, we'll also make sure that those get answered as well. Also, what we'll be doing at the end, I know a few people have asked us to send them the data set. We'll be doing that to all webinar attendees as well. We'll be making sure that you get this data set from today's use case to play around with as well. So, like I said, for those of you who are new to Marlyn, I just want to give you a little bit of a refresher or a starter for what exactly our drone is. Well, basically, Marlyn is a vertical takeoff and landing, or VTOL, surveying and mapping drone. So what that means is it takes the advantages of a multi-rotor drone, which I know a lot of you are using, and the advantages of a fixed wing or airplane style drone, and essentially puts them together. And what it also does is it removes the disadvantages of a multi-rotor and the disadvantages of a traditional fixed wing drone. What are those? Well, typically with a multi-rotor, you're able to take off and land everywhere, but you can't really cover big areas. The result of that's the result of the propellers being used to keep the whole weight of the drone in the air, so it's not that efficient. With fixed wing drones, of course, they use their wings to stay in the air, but traditional fixed wing drones, they have to belly land when they come in, which is basically like a controlled crash. And for those of you who are belly landing fixed wing drone users, you'll be used to looking for big 100-meter long areas in order to land your drone, which is just not that practical if you're a surveyor, especially if you're working in those really tight environments as well. So when you get Marlyn, you also get the opportunity to cover a lot of different applications. And we're always really surprised at the breadth of different applications that are possible with Marlyn and that our users are going out and doing. So we have, firstly, on the left, the Sony RX1 full frame RGB camera. It's a 42 megapixel camera. It's like the Rolls Royce of surveying cameras at the moment. And this is used for your typical surveying and mapping, mining, forestry type of use cases. But we also carry multispectral cameras. So you can see here the high resolution MicaSense Altum camera, which also carries a thermal sensor. And then also the MicaSense Red Edge MX, MicaSense's entry-level multispectral camera. Now, the best thing about these sensors is that if you want to do a variety of different surveying, it's possible to change through these payloads in the field. So if you want to go and do an RGB survey and then switch it over into a multispectral survey, that's possible by swapping in and out our payload module in about 5 minutes in the field. Also, we carry Septentrio's PPK system, which is, again, the Rolls-Royce of PPK units, which are available on drones at the moment. So when combined with the Sony RX1 42 megapixel camera, that's where you get your really fine GSDs and your really fine accuracies as well. And the best thing about our PPK is that it's also usable with the multispectral options. So often I get the question, what's the difference between you and a lot of other fixed wing and VTOL type drones? There are not many VTOL drones in the world that are capable of having PPK in operation with multispectral cameras at the same time. So if you want to get those good accuracies without using GCPs, it is absolutely possible with multispectral cameras and with Marlyn. Also, if you wanted to perhaps take advantage of some cash flow in your company and get a Marlyn but not pay extra for the PPK, it is possible to upgrade to that afterwards. So if you wanted to buy a Marlyn and then 6 months later buy the PPK, that is totally fine. And how does Marlyn benefit you? Well, like I said before, just like a multi-rotor, you have the opportunity to take off from any 2x2 meter area. So if you're someone who works in forestry and you typically have to take off or land from a forest clearing, then that's totally possible with Marlyn. Also, after you do that, you transition into airplane mode, and then you can cover up to about 100 to 150 hectares within a 50-minute flight time. And again, the other big difference point between us and other drones is our wind resistance. There is no other fixed wing drone in the world that's capable of taking off and landing in 45 kilometers an hour of wind regularly. Then when you transition into airplane mode, this translates in up to 55 kilometers an hour of wind resistance. If you're operating in a very windy area, when compared to other fixed wing drones that can only take off and land in, say, 30 kilometers an hour, they can give you up to 30% more surveying in every month. And think about what that can mean for your return on investment. On top of this, while you're doing your survey, it's possible to get imagery down to 1 centimeter per pixel GSD, and also get centimeter level accuracies without GCPs. But I'll let Norbert go into that. And what I'm going to do now is I'm going to pass over to Norbert, who's going to tell you a little bit more about a real world use case with Marlyn. Oh, I believe you're on mute still, Norbert.
Yes, I was. Well, thank you, James, for having me here on board. I am going to share my screen for you so you all can see what we are going to be talking about. Today, I am going to take you with me for a, well, small user case we are working on in the Netherlands. And based on all these points, we are going to have these things explained. So, small introduction about who am I, about the project itself, of course, flight planning, quite necessary to do, I guess, the logistics, the data handling, and also the results and the accuracy we found with Marlyn. So let's start with who am I? Well, my name is Norbert, and well, already mentioned that by James. I am the Chief Aviation Officer of a company in Holland, which is called Blik van boven. In English, glance from above. Well, yeah, I think I'm quite experienced. I have 1,000 plus on flight hours on a UAV, so not on a civil plane, but on UAV. And well, I have a lot of experience with geospatial data, especially when it's done by a drone. When we move over to the project which we are in, our end customer is the University of Twente, and we work together on this with Ilke Volmer from the company Area. And Ilke is a data specialist, and well, I am the drone part specialist of this. The request we've got is that if it would be possible to deliver high accurate centimeter level measurements on sediments out on salt marshes in Holland. And well, you can see it here on the small picture. I made a red circle on it, and well, that's the area in which we are going to talk about. And well, what you can see, it's at sea level. So for us, it's located in the Dutch Wadden Sea, and that meant it's also a very challenging environment because we are only able to make our survey at this specific places during low tide. And what we have a time frame of 4 hours for that. The environment itself, and you can see it in the other picture, is on the background. Well, that's changing the whole time. Every time when we have a new fluid come up, well, that sediment will change also a little bit. So it's really important for us, if we plan flights or something like that, that we take care of the 4-hour time frame we have. Another thing is that it's quite difficult to access this specific area. It's really muddy. It's on the bottom of the sea. Usually there is, well, 2 to 5 meters water on top of it, normally. So yes, it's very muddy. So that also means that putting checkpoints or ground control points or something like that out in the field, well, that's quite difficult to do. And well, another thing we have to take care of is that we always have some reflecting salt water on top of this surface area. If you move over to the flight planning, and I already mentioned a little bit of that, what we like on the Atmos Marlyn systems is that we have the ability of making use of Marlyn, which is their software platform, their ground station. And flight planning you can do at home or at the office. So it's not necessary to do that out in the field. Well, what you can see here is that setting up a flight plan in this specific location, it's quite challenging. We have to take care of the low tide, which I mentioned. We only have 4 hours and the water will flow out. So on top of these lines where you see the arrows. And later on it will come back, of course. So we have to be very fast and we have to take care of where are we going to start with Marlyn. The order of the flight lines also is very important. And what you can see in this picture is that usually Marlyn is in a dynamic mode. And that means if you start at line 1, which is on the left arrow, you see that if we move over to the right, Marlyn will skip 2 flight lines before it going to position line 2. And that's on a salt marsh area. Well, that's not what you want to have, because that will mean that you will not fly it line by line. The good news is that Atmos also makes it possible to select basic instead of dynamic. They have 3 different types of how you are going to set up a flight plan. It's dynamic, that's the most efficient term for Marlyn itself. You have basic, then you first will have line 1, then line 2, line 3. That's what we need at the salt marsh. And you have interlaced. And that means you will first fly line 1, then skip 1, go to line 2, etc. What is challenging for these kind of flight plans, and I will move back 1 slide for that, is that we always have to position them in line with the coastline we have. Also, of course, because of the water. And well, that means that you cannot always plan it in an efficient way regarding to the wind. I will show you later on a little bit how Atmos will take care of that one. Marlyn itself, well, it flies quite well, even if the wind is coming from, let's say, worse directions. We were very pleased with that one. The logistics, of course, also, well, they are challenging. We are going out on a mud flat, a salt marsh on the bottom of the sea. Now what you can see, I've set in some various pictures of this one. You can see we have a backpack with us, which is from Atmos, of course, and that contains everything you need for getting out in an environment like this. they have a special pocket in which you can put on your pole, which you need for your base station. There are a lot of pockets outside which you can fill with batteries and that kind of stuff. And you also can see on the right in the picture, they have a compartment in the back in which has your remote control, your laptop, that kind of stuff. So to make a long story short, you have everything just in one bag. You put it on the back and you walk in. You're not able to drive by car or something like that, or a quad, or, well, think about something, because there are big creeks which you have to pass with a lot of water inside. So, well, you have to be aware of that. The backpack really helps. That's quite nice to have. If you have done all your flights, if you're ready with it, you go back to the office. And that's where the data handling will start. And well, what I would advise is you will have 3 data streams. One, of course, are all the pictures you've made with Marlyn. The other data stream is your PPK rover data, the data from Marlyn itself, the PPK correction data. You also have the autopilot data, and that's an important one, because the autopilot data, well, it will tell the system, the GeoTagger system, in what angle or heading the machine was in flight. So that's what you need for corrections on your PPK also, of course. So if you put it in separate folders, a folder with the pictures, a folder with the PPK data inside, a folder with your RENEX data, your base station, or whatever you want to have, you can just drag and drop them in this GeoTagger software. And what we personally really love about this part is that you can see here, you can see all your flight lines, you can see every black dot, which is the position of an image which is taken. And you also can see in the green dot where your rover data is coming from. Last thing you can do is you have to select, do you want to write all these data into the EXIF files of your pictures? Or do you just want to have a CSV file which you can handle yourself? If we compare this with what we formerly used, we used an Emmet. Well, this is quite easy to use. You cannot make any mistake with this one. We really liked it. It's just drag and drop, and you will be visually seen what you've done. What comes out is a very nice document. And what we really liked of Atmos is that the GeoTagger offers you separate types of files. So if you are like us, a user of Metashape, you will have a data file which is also named Metashape. And if you open that one, you will have a document like this, in which you can see also the correcting of the accuracy based on the yaw, the pitch, the roll, that kind of stuff. You also have a version of this specific for Pix4D. We do not use that by ourselves, but in Pix4D, you make use of, as far as I remember right, Gamma, Delta, that kind of stuff. They take care of it for you. So with the same GeoTagger, you get various types of files which you can implement in your own type of software. I think that's a real benefit. What also very nice to know is, and that's where the accuracy comes in, I guess, is that the GeoTagger also takes care of handling the altitude orientation of Marlyn related to the position of the camera. We are flying with a virtual takeoff and landing machine, so it behaves like a fixed wing. There is no gimbal inside. So that means if Marlyn flies in an angle or in a heading, your picture also will be different than if you will do that with, for example, a Phantom or something like that. GeoTagger knows how the picture is made, from which heading, which angles, that kind of stuff. And it will correct it via this file. So what about the results? What you can see then? And well, this first picture, I just show you an average camera error. So this is, well, nothing to do with accuracy or something like that, but it tells you, it informs you about the quality of the pictures itself. So what this sheet shows you is, okay, what was the calculated position of this camera, of this picture, related to the projected version of it. And there you can see, well, it's quite accurate. You can see, well, it's just on centimeter level. It's also what we expected. So what kind of accuracy Marlyn will bring us? And well, I don't know if everyone is, well, a surveyor. Maybe we also have people who are not aware of the difference in between a relative accuracy and an absolute accuracy. But I will explain that. The relative accuracy is if you have a known point in your model, so you know sizes of points in your model, you can let your model calculate, okay, what's the size of what I see here? And in this case, you can see we had the propeller arrow points with us. These were our checkpoints. And there you can see the calculation in the model tells us that is 54.5 centimeters. On the right, you see a specification coming from the manufacturer of the propeller arrow point. And there you can see the original size of it is 45 by 45 centimeters. So that means we have a very high relative accuracy because the original measurement is 54 and we find 54.5. And this accuracy, of course, is under influence of the ground sample distance. And the ground sample distance, that is the number which tells you every picture in my, every pixel in my picture has a size, in this case, of 1.3 centimeters. So getting an accuracy this high, that's really good. So now what about the absolute accuracy? Well, usually if you move out in a field and you're going out for mapping, you bring a PPK unit with you, and that's necessary in an environment like this because you cannot fill it out with all your checkpoints over the whole area. It's always advisable to put some in places where you can come. And what you can do then is these checkpoints, you know the exact position of that one. And if you have your model on top of it, then you can see, okay, what's the error I have on my position of my checkpoint in my picture related to the real world position. Of course, they have to be in the same data format, otherwise you can't do that. But what we see here, and that's for us very important, we have an absolute accuracy of 1.8 and 3 centimeters on the horizontal axis and 5 centimeters on the vertical axis. Well, that's good. It's not necessary for measuring sediments on the salt marsh to know the absolute accuracy. There, the relative accuracy is very important because if you want to measure differences, well, it has to be compared with the original size. But it's always very good to know that the Marlyn also is good in an absolute accuracy. To show you a little bit of, but what brought it to us. This is one of the results when we started in 2019. We took a phantom with us and we modified that one with a UAV designed PPK unit from Marlyn. And on this area, we were able to fly for about 50 hectares. We were flying at 45 meters altitude, but we needed for about 7 hours for that. And the low tide, as I mentioned, is just 4 hours. But the part on the left of this picture and the left bottom, that's ground level. So that's countryside. Sorry, I meant countryside. So that's not specific salt marsh. So that means we had some more time and we took that also with us. So let's say 1 day flying, it brought us for about 50 hectares. This year, well, last year in 2020, we did the same field, but then we brought Marlyn with us, a virtual takeoff and landing system. And then we get this. We had as a payload the Sony RX1RII inside, a 42 megapixel camera. That meant that we could fly for at a level of 100 meters altitude instead of the 45 meters. We've flown with Marlyn for about 300 hectares in just 2 hours and 40 minutes. That's quite much, I guess. It will show you a very huge difference in between the two. So that means Marlyn, well, it's 12 times more efficient than using this, than doing this same project with a Phantom. Cool. About some of these results. So what are we doing with these data? To get back to the salt marsh, the whole idea of a salt marsh is that it will protect Holland, the Netherlands, in a natural way. So what we do is we have dikes, of course. And what we do is at the Wadden Sea, in front of the dikes, we are setting up an area in which the sea drops up new soil every time we have a high tide. And that way it will get higher and higher, slowly and slowly. There will be coming in some plants and that kind of stuff. We will grow up higher and higher, and we have a natural protection of the Netherlands itself. And that's also the reason why it's important to know how efficient is this kind of area for us. Well, that's what we are measuring with our Marlyn and our Phantom in the past. And on the left, you can see an image with a red line and a blue line in it. And there you see two spikes in it. And these spikes are where we have in the field outside, we have poles. So these spikes are just showing where we're popping over the poles. But what you also can see is that there is a difference in height in the red line and the blue line. And what you see is that the further we go to sea level, more difference we get in just 1 year. So this is the difference in between 2019 and 2020, which is, let's say, for about 5-6 centimeters difference in height. On the right, you see a set of data in which we do some various kind of measurements. And the T3 one, that's the dike. We have a dike there. And well, if you put a line on that, it has to be, well, almost flat, as you can see also. So yeah, to summarize it a little bit, we found a very good accuracy in the relative way, more than we expected, very high, 54.5 centimeters we measure on an original thing of 54 centimeters. So that's, well, that's perfect. And well, what was also very nice for us, we have it in the backpack. So we just can walk with all the things on our back in the field. And well, it's 12 times more efficient. And yes, of course, we expected that it would be more efficient than, let's say, the Phantom, but we didn't expect that we will fly 300 hectares in, let's say, 2.5 hours. That's really cool. So this is for me my part of the presentation, and I will hand it over back to James.
Excellent. Well, thanks a lot, Norbert, for sharing your use case with us. It was really, really interesting to hear about. But I think, look, before we jump into the general Q&A, I'd be quite interested to ask you my own questions, actually. But what I think a lot of people will be quite interested in as well is, so what was, in terms of using Marlyn, your biggest challenge that you found actually from using the drone?
Well, yeah, that's a good question. You know, I compared it a little bit with a Phantom. And one of the challenges we had when we were out on the salt march, and we've been on several spots. This was just an example of one of these different spots we were. What we found out that a salt march, well, of course we knew it's really muddy. But what we didn't knew was that if you put Marlyn on top of it, it just will sink slowly and slowly and slowly. So we had to take care of that one. And that was quite challenging. Later on, we took a, how you call it in English, a sail, I guess, a sail with us in which we put it on top. And that, of course, that helped.
Okay. Interesting. Interesting. So it's it was like quicksand, very slow moving quicksand.
It is.
To drone onto.
It is.
And I mentioned before about the wind conditions. Obviously, Marlyn can do fly in higher winds than all other VTOL drones. What were the wind conditions like for you when you were out on the salt marshes?
Well, that's again a good question, of course. What we experienced is, in the beginning when we started, we were a little bit afraid of flying Marlyn because in the vertical takeoff position, well, it just catches a lot of wind because it's quite a big plane, you know. But what we saw, and we were really surprised about that, it can handle more wind than we could do with the Phantom. And that meant that we were, at the salt march, there's always a lot of wind. We are on top of the northern part of the Netherlands, and there is nothing just in front of you which will catch up the wind for you. So there's always wind. And we were able to fly it. I saw you mentioned, what was it, 45 to 55 kilometers an hour. Well, we landed it, sometimes we landed it at a wind with at least 12 meters a second. So that's in, well, like you mentioned, something like that. And at height, flying at 100 meters, you have, well, it's not a big difference if you're at the salt march, because on ground level, you also have kind of the same type of wind which you have on top. But I think we've flown it in between 12 to 50 meters a second also, and that's really good. And what you can see, if you fly it, you would expect, okay, you will have a heading and that kind of stuff, and you will have angles. But the GeoTagger, which you can use later on when you're back on the alphas, wow, these results are fantastic. Yes, we were a little bit afraid, but well, we are very surprised about how much wind it can handle.
Good to hear. Good to hear. And then finally, have you had some feedback from the end customer actually about the results? Were they happy customers?
Well, yes. What it brought us, we didn't tell the customer that we would go out this year with Marlyn. So they expected similar results like we had the year before when we flown with the Phantom. So to say it in other words, when we sent them over our digital elevation models and or auto pictures and auto photos and that kind of stuff, they expected to get a picture for about 4 or 5 gigabyte big in size. But this year, based on Marlyn, well, these pictures were for about 60 to 70 gigabyte each. So the first time when we sent it over, they gave us a call. What are you sending us? We still downloading, you know? So then we explained. About the quality of it, well, yeah, you know, what we already get some new details for moving on for this year. So yes, they are now looking at how can we make it even bigger than we have now. So we now flown, most of it is flown on the mud flat part, on the salt marsh part. And they are, well, we are talking now about flying over for the whole northern part of the Netherlands. So I don't know if it will be done this year, but we are in that kind of discussion. So yeah, well, that tells us that they are very, very satisfied with it.
Very nice to hear. And I hope you guys out there also appreciated hearing a surveyor's perspective of what it's like to go out with Marlyn. So thank you very much, Norbert.
You're welcome.
So what I will do is I will just jump on my screen share now. So for you guys out there, if you have liked what you've heard, one of the first things you can do is to jump onto our website, atmosuav.com, and go to where to buy. And there we have a complete coverage of our global network of distributors. So we have Marlyn distributors at the moment on 6 continents, and most of them are also flying Marlyn drones, and we'll be able to give you a demonstration as well. And also, if you are perhaps viewing from a country who doesn't have a reseller, that is not a problem at all. You can get in touch with us at our headquarters in Holland, and we will be more than happy to help you out. So what we're going to go into now is our Q&A section. But firstly, we've obviously had the time to have a bit of a yak about Marlyn, about what we can provide. But we're also really interested in what your survey stories are and what some issues that you may be facing and how we can help with that. So one of my colleagues is actually just going to put up a poll now. And on there, you can indicate if you are interested in setting up a video call with us and setting up a video meeting with one of our representatives. Also, if you'd like to find out more information, if you'd like to get in touch by email. So you can indicate there, and through the magic of modern technology, what we'll be able to do is to get your email address from that, and one of our reps will be in touch tomorrow, and we'll be able to find out a little bit about what your issues are and how potentially Marlyn can help you out with that. But also, a lot of you indicated before the webinar started that you'd be interested in getting a data set to have a play around with yourself. What we're going to be sending to every one of the attendees to this webinar is an email. And in there is going to be a data set, firstly a LAS file if you just want to go straight to the point cloud, but also some images and geotags if you are interested in doing the processing in Pix4D or Agisoft yourself. On top of that, we'll also have a recording of today's webinar if you want to share it with some of your colleagues who perhaps didn't have a chance to join us today. But otherwise, I just want to thank you. We had literally hundreds of attendees today, and it's really nice to get the opportunity to share some of Marlyn's capabilities with you guys. And so what I'll do now is I'll invite you all to put down your questions and answers in the, your questions in the Q&A box, the Q&A icon down the bottom, and then Norbert and I will do our best to answer those. So just jumping into it. So Howard Krasinski asks, do you need to run your base station on a ground control point to get the high accuracy? Did you want to handle that one, Norbert?
Yep, I will. I will put my camera back on, I hope. Yep, here I am. Well, you can handle it in several ways if you want to do it. If you are working with a base station, so you have the base station with you on the pole, and you also have, of course, the rover data from the Marlyn itself. For high accuracy, if you want to have it on an absolute way, then you need to have a known point. So then the base station has to be positioned on a known point. If it's based on relative accuracy, then that's not necessary, because then only the accuracy you need to have is relative to the known object. So to summarize that, for absolute accuracy, yes, you need to know the position of the base station. For relative accuracy, no, that's not necessary.
Excellent. Thank you very much, Norbert. And what else have we got here? So Mukesh Sharma asked, what is the maximum flight height? So in terms of altitude above sea level, we have flown with a standard Marlyn in altitudes, I believe it was just over 5,000 meters above sea level. This was in Ecuador. It was also with the full wind conditions as well. I think the winds were blasting at about 45 kilometers an hour at that time, and they were still able to cover about, I think, 100 hectares in the single flight. So really, because we have a set of propellers that are specialized for the helicopter mode and a set of propellers that are specialized for the airplane mode, we're able to operate in our most efficient operating point for each of those flight regimes. I think, you know, because each of them has a specific RPM and torque that is required to be optimal at that point. And I think there are certain drones out there that don't have that, which may limit your ability to operate at those flight heights above sort of 3,000 meters. But with us, it's not an issue. Does the Marlyn bundle package also include the GNSS bundle from Krishna Subianto? So we can also include a PPK base station in with your Marlyn bundle. We don't include it as standard because most users will find that they already have a base station which they use for surveying. So you can use any base station which is capable of outputting a RINEX 2 or RINEX 3 output. And even if it doesn't, then it is still possible to usually convert that base station data. I know Norbert, for example, was using an MLID base station, and it was also compatible with Marlyn as well. We also do recently have a compatibility with TopCon's TopNet subscription. So if perhaps you didn't want to make that big investment in a base station, which it is, you know, a few $1,000s, you can also subscribe to TopNet. I'm not sure what the monthly cost is, but it's significantly less than purchasing a base station, and they have the majority of the world covered. And it is possible to have that compatible with Marlyn. Justin Huntley asks, is the system compatible with Trimble equipment? I think that's similarly answered in the last question. I believe Trimble doesn't, as standard, output RINEX data. I'm not sure if you know anything about that, Norbert, but I think we've had some situations in the past where some customers have used it, but I think Trimble has a free to download software, which is going to allow you to convert your data from the base station into RINEX, and then it's fine. You just have that extra conversion step. Sorry, go.
What I saw in GeoTagger is that you can handle a lot of various types of data. Well, we use an MNet, for example, like you mentioned, but there are several types of units you can handle there. As far as I understood, you need to have RINEX data.
But it's possible to convert. So you have a RINEX, I think it's a .to5 file that you get from a Trimble base station, and then Trimble has a free to download software that you can use to convert .to5 to the RINEX, and then it's possible to put into GeoTagger. Is it possible to do post-processing on flight position to enhance the accuracy of the data? Also from Krishna Subianto. So what I believe you're asking here is it possible to include in the post-processing the position of the drone, so the angles of the drone? So yes, this is possible. So we have our own autopilot software and hardware, which basically means that we have all the data after the end of every flight. And as Norbert would have told you, one of the streams of data that you use in the GeoTagger is your autopilot file. So within there is all of the angles of the drone. I think it's phi, gamma, and beta. Norbert, can you recall the names of the angles that are used there? But all of those orientation angles for each timestamp are included in the information, and they are also fed into Agisoft. Sorry, Norbert, you can elaborate there as well.
That's correct. The GeoTagger, and we think that's one of the main benefits of using Marlyn instead of, let's say, emlet-based units which you have made by yourself or something like that. So Marlyn handles the data from the GeoTagger in various types of documents. So you can implement it directly into Pix4D, for example, or they also present you a version which you can take into a Metashape because it has a different type of format. So the GeoTagger takes care of that one. So yeah, it will be pushed out in a type of format you like to have.
Thanks for that, Norbert. What else have we got? Isn't Autopilot open source or special? So our Autopilot's being completely developed in-house, but it's not open source in the sense that you're able to make your own adjustments to it. But I believe that was answered in person as well. There's a lot of questions about potential new sensors. So I think in general, what I can answer to those is that Marlyn's payload bay is modular. So we have a maximum payload weight of 1 kilogram. So anything within that, it is technically possible to fit into the drone. I think each payload needs to have quite a bit of R&D in terms of developing the optimal integration, because the difference between, say, a multi-rotor and a fixed wing when you're implementing new sensors is that on a fixed wing drone, a new sensor is going to alter the weight balance of the drone and the flight dynamics. So it's not as simple as bolting a new sensor on. There's certainly a lot of R&D work that goes into it, but it's definitely possible to implement new sensor options. And these will be things that we will keep you posted with on social media and also through new webinars and things like that as well. Our R&D team are always hard at work on new exciting things to bring to surveys as well. But I think that we've come up to our time now. So for those who have further questions, we will be sure to get in touch with you by email. So we have all of your questions and we have all of your email addresses. So fear not, we will certainly be in touch. And I just want to thank you all again for joining us. It's been fantastic to share some more of Marlyn's capabilities with you. And I wish you all a very good day wherever you are in the world. Thank you very much.